Now dear student, we are going to discuss question number 2.36, and in this question it is given to you. You have to give answer of the following questions. Number A question is given to you. The top of atmosphere is at about 400 kilovolt with respect to surface of the earth. Fine. Corresponding to an electric field that decreases with altitude near the surface of earth, the field is about 100 volt per meter. Okay, fine. Why do we not get an electric shock as we step out of our house into open air? Clear? Now listen carefully. Actually, what is the given situation? Situation is given to you. Top of atmosphere is at 400 kilovolt with respect to surface of a earth. Okay, fine. And at, we can say, near the surface of earth we are having electric field 100 volt per meter. Clear? So let's suppose, if we talk about, let's suppose this is ground, and if we talk about equipotential surface, equipotential surfaces are always parallel to ground. Clear? It is given here that electric field is actually decreasing as altitude is decreasing. So let's suppose if we are assuming electric field is vertical, we can say these equipotential surfaces are perpendicular to this electric field. Clear to everyone? Now important part is here, why whenever we have electric field such much amount 100 volt per meter, then why we are not getting electric shock when we are coming out of our house? So actually what is happening, listen carefully. Actually we can say our body is a good conductor. Clear? So as we come outside of our house, we can say equipotential surface becomes like this. Yes or no? So we can say equipotential surface become like this. So actually we can say, if we talk about potential difference between these 2 points, our head and our leg, we will find a very negligible or almost zero potential difference between these 2 points. Clear? So whenever we have no potential difference, we can say the charge cannot be flow. Yes or no? And it means we can say we will not find any electric shock. Clear everyone? So this is answer of this question number A. Clear to everyone? Yes. Now if we talk about a man fixes outside his house one evening a 2 meter high insulating slab carrying on its top a large aluminium sheet of area 1 meter square. Okay. Actually what is happening? Let's suppose this is ground. Let's suppose this is ground. Clear? A man fixes outside his house a 2 meter high insulating slab. Let's suppose here we have, this is 2 meter high insulating slab. Clear? A person is doing what? An aluminium strip is actually fixed at this position. Clear? And let's suppose this is a person. Now what is happening? If next morning that person touches the aluminium strip, it will gain some electric shock or not. So according to me, definitely you can assume this situation like this. Here we have a metal plate. We are inserting a dielectric between 2 parallel plates, and you can assume this ground is also having a parallel plate like this. Yes or no? It means we can say this becomes a parallel plate capacitor having a dielectric slab between these 2 parallel plates. Clear to you? Yes. So now if we, in the next morning, if we say this person is touching this aluminium sheet, so definitely this will get an electric shock. Why? Because we can say from evening to morning, definitely some charge that is stored in this capacitor according to the capacity of this capacitor. Clear? So as the charge is stored in a capacitor, we can say as this person touches this sheet, definitely he will get some electric shock. Clear? So we can say this statement is correct, and this one we have already talking about. Clear to you? So this is part number A and part number B of this question, question number 2.36. Now dear student, we are going to discuss part number C of question number 2.36. In this question it is given to you, the discharging current in the atmosphere due to small conducting of air is known to be 1800 ampere on an average over the globe. Fine. Why does the atmosphere not discharge itself completely in this course and becomes electrically neutral? Clear? A very interesting question we have. Whenever we are saying that atmosphere is discharging a current that is 1800 ampere, so from where atmosphere is getting some charge? Actually we know on our earth we have a different places. At some places we are having thunderstorm, at some places we are getting lightning. So actually the equilibrium of the atmosphere is maintained by these we can say by these electric we can say lightning. Clear? So some equilibrium in electric charges is maintained by lightning, thunderstorm and so on. Clear? So we can say if at one point earth is actually discharging some charges, or we can say discharging some current, so we can say at the same time on other place the atmosphere is getting charged, and we can say equilibrium of this system is maintained. Clear to you? So I think this question is clear to you. Clear? Now dear student, we are going to discuss question number 2.36 part number D. In this question it is given what are the form of energy into which the electric energy of atmosphere is dissipated during lightning. Actually now we know during lightning the electric energy of we can say electric energy of the atmosphere is dissipated in the form of we can say light energy. It can dissipate in the form of heat energy. It can dissipate in a form of sound energy. Clear? So very simple question we have. Clear? Now it is given the earth, hint is also given to you in this question. Earth has an electric field of about 100 volt per meter at its surface in downward direction. Fine. Corresponding to a surface charge density, this is given to you on earth minus 10 to the power minus 9 coulomb per meter square. Okay. Due to slight conductivity of atmosphere up to about 50 kilometer, beyond which it is good conductor, about 1800 coulomb is pumped every second into earth as a whole. Fine. The earth however does not get discharged since thunderstorm and lightning occurring continually all over globe. Clear? So that actually hint is useful for part number C. Clear? But you should keep in mind what is solution of this question. The energy that is dissipating in the form of we can say heat energy, in the form of light energy, in the form of sound energy. Clear to everyone? So this is all about this question.